Hi everyone, welcome to 3sweep user manual. 3sweep is an interesting software which could help you extract 3D models from a single photograph. If you have any questions about the original paper the software is based on, or some implementation details about this software, don't forget to visit cg.cs.tsinghua.edu.cn. I have put all of the detailed information in the description below. So, if you have any questions, don't forget to check out the description or leave a comment. Let's get started. First of all, basic operations. When you open this software, you could click on File, Open Image, or simply click on this button on the left to load a new image. Here we're going to choose tower.png as an example. When you click on Open, you will see a border detection pops up. This implementation differs from the original paper in that it didn't use the GPP-UCM algorithm for border detection because the speed of GPP-UCM is too slow. So we're going to use basic canning method for edge detection. You could just press the slider and drag it until the border detection result is satisfied. After that, you press OK. Then you're going to choose the model type on the right. Here, because this tower is in a cuboid shape, we're going to choose this icon, Model Box. So then you could actually start your modeling process. So the first thing you need to do, of course, is to make your first sweep. You put your mouse on the desired position and then click on your mouse and drag to make the first sweep. Release your mouse. Then just move your mouse to make the second sweep. Click to confirm. You could see that a 3D model was automatically generated. Then you just move your mouse along the main axis of your model to make the third sweep. Please note that the current implementation of 3sweep does not automatically estimate the intrinsic parameters of the camera for you. So you have to adjust the field of view yourself. This could be achieved simply by rolling your view. If you want more precise control over the FOV, you could simply press Control Modifier. After you are satisfied with the results, simply press your mouse button and the model is completed. You could select the model by simply clicking on it, and as you can see, the border turned red and actually the roof turned blue. And after, you can deselect it by simply clicking on the other side. So the model is now deselected. So let's start to give it some texture. First of all, you should select this model, and then you're going to press the second button on the toolbar. It is called Assign Texture to Selected Meshes. You press it, and here a dialog prompts. It says, do you want to use patch match algorithm to remove the foreground? This may take a while. Actually, for a picture like this big, it will take around 9 to 10 seconds to remove all of the foregrounds, which is the tower itself. Actually, the time could vary on different machines, and basically that's what we have on a laptop computer. So we're going to choose yes. So let's just wait for a second for the patch match algorithm to be completed. Okay, the operation is completed. Then I'm going to introduce you to how to move this model around. In 3sweep, there are 4 modes in total. The mode we have just used is called the modeling mode. The second mode is called manipulating mode, and this viewing mode and border edit mode. Actually, you can hover your mouse over this icon to see what you can do within this mode. I'm gonna choose Manipulate mode. Manipulating mode allows you to manipulate the model, like scaling it, translating it, or even rotating it. So let's just select this model by clicking on it, and then use your right mouse button to rotate it. You click on your right mouse button and drag, so you can see that the model is rotated. You can also use your middle mouse button to translate it. You press your middle mouse button and just move around to see how it is translated. And you can always use your mouse button to scale it. There are 4 viewing modes in 3sweep. The first mode is called Normal Picture, which displays the original picture. The second mode is called Background Picture. In this picture, it displays an image without the foreground. And also, we have the border picture, which displays the border we have just extracted, or the labeled border picture, which is described in the original paper, which could group similar patterns into a whole group. You could simply copy the model by clicking on Ctrl+C and Ctrl+V, so that you have 2 models. You can drag to select both, and rotate or translate both, which are all fine. Next, I'm gonna show you how to use the viewing mode. Viewing mode won't change the model itself, but change the camera. You could always open the grid here to show a 3D grid. The operations available in viewing mode is roughly the same as in manipulating mode. You use your right mouse button to change the rotation of the camera, or you use your middle mouse button to pan the view, or you could zoom in or out the camera by using the mouse wheel. You could always restore to the original view by pressing on this button. It's called Restore Camera's Position and Rotation. After you have pressed it, all of the positions are restored. So this is the end of the basic operations, and next I'm going to show you how to use the optimization function. I'm going to demonstrate you this function by simply using another image. You could always change image by pressing on File, Open Image. This time we're going to use this round.png. When I open it, it prompts me that a previous drawn edge file is found. Do you want to load it? This happens when you actually save the border file. Please note that if you want to save the border you have already edited, you can always press on File and Save Border File. So the border file will be automatically saved within the same folder of the image. Because this ways is generally a cylinder, so we have to use this cylinder mode instead of this box mode. Well, drawing a cylinder is actually exactly the same as drawing a cuboid. First of all, you put your mouse onto the first point, press your mouse button and drag to make your first sweep, release your mouse button, move to make your second sweep, and then move your mouse to make the third sweep. Press to confirm. After you have finished this first sweep, you can make the second sweep. It's exactly the same, but please note that using the first 3 sweeps described before would just generate a straight mesh, which is not a generalized cylinder. So what you should do here is to, make sure the direction and press the right mouse button, and then use your mouse to track the mesh. You should handle it with care, because this is very tricky, and it actually the quality of the mesh just depends on the trackball mouse largely. In this example, we could change to shaded mode and take a look. We found that this T-port, the main part and the bending part does not align correctly. Actually, they should lie on the same plane. We'll need to use this constraint mode to solve this problem. We'll click on this icon and open the constraint window. So there are many kinds of constraints we could select from. In this case, we're gonna select coplanar constraint. We will use the select tool to click on both model to select both, and then we could use these small tiny icons to give them constraints. So this is the coplanar constraint. It says coplanar axis, and you could always add like overlapping axis endpoints, coplanar axis endpoints, or the parallelism or orthogonality. You could select one constraint and press delete on your keyboard to delete the constraint. When you decide which constraint to use, you just press this icon. It's called optimizing. You press it and look at the optimized result. We use the view mode. Pretty good. I think it's much better than before. I think this model is ready to use. Press this icon to restore default camera position and give it a texture. So 3sweep offers you the functionality to export the model to OBJ file, so you could always load in this model into your favorite mesh viewer and check out the results. So next, I'm going to show you how to use the border edit tool. When you load an image, a dialog will automatically prompt up. You can choose canny or grab cut algorithm to select the border of the image. For example, in this case, we're going to use grab cut algorithm. First of all, you should draw a bounding box, and then you should shift click to draw the foreground, and control click to draw the background. The foreground is marked in red pixels, and background is marked as blue pixels. After you have finished marking, press N to use grab cut algorithm to make an iteration. So when you finish, don't click on the close button, instead click on enter button. So when you're finished, you could change to the border edit mode. When you're in this mode, a blackened version of the picture will be overlaid on the border, so you could actually see it better. You can use pen tool to mark the border, or use the erase tool to erase the line that you have drawn. Please note that our system, by default, our system will not save the border you have drawn automatically. If you want to enable this feature, you could go to File Settings and mark the automatically confirm border tick, so that will automatically save it for you when you change to the other mode. So next, I'm gonna introduce you to how to use this pen tool. It's very intuitive to use. So when you click on the canvas, and it will automatically create the start point, and then you just click on the second point, and so on. It will just draw the polygons. If you want to confirm the current polygon, you just click on the right mouse button. You should be aware that along with our software, we have provided you with some demonstration pictures. Most of the pictures have a predefined boundary file, so we call it border file, so you don't have to manually draw the border yourself. But if you have a picture that you have imported casually, and canny edge detection or grab cut algorithm just won't provide a good or feasible result, you probably need to draw the border yourself. Actually, for 3sweep algorithm, the border detection result is crucial for later performance, so you really have to handle it with care. In this example, because the middle cuboid is a little bit strange, the position is a little bit strange, so we cannot directly use the algorithm to draw it, to model it precisely. So we choose to just first draw a cuboid and then rotate it to the desired position. So in the very first example, we will going to model this samovar. First of all, we will going to add a cylinder, and then the base. The base is actually a cuboid, so we have to use change it to the cuboid mode, and then the two supporting base. Note that you can always hit R to re-snap the model to the image boundary, which we will introduce later. And then this bending part, you should right-click to enable bending mode, and then you could model the other part. So in this constraint window, we add 4 constraints. They are all coplanar constraints. We add these constraints so that the 2 handles on the left and right, and also the handles on the top, they are actually lies in the same plane as the main body part. One problem we found is that when we rotate the left and right handle, we found the texture is a little bit weird. It has white paddings. So we're going to File, Settings, Texture Panel, Texture Extrapolation. After we have enabled this, we select this 2 handle and click on the Texture Assign icon. We will find that we select all the other parts and press this button too. And we will find that the system automatically extrapolates the texture so that the boundary of the texture looks, more natural. So in this example, we are actually going to model another beautiful ornament, and it's actually another candlestick. Just like this, we're going to use the border provided. In this case, I'm going to show you how actually the optimization parameter influence the final model look. So we're going to first model this part that holds the candle actually, and then the main axis. We are going to break this into 2 parts because later we hope that we could actually rotate the candle, the part that holds the candle. We're going to shaded mode and check it out, and found that these 2 parts are not correctly aligned. But in the original picture, obviously these 2 parts are connected together. So we're going to give it overlapping axis endpoints constraint. Looks like our optimization parameter, it prefers endpoint change. We're going to press optimize and just rotate it, and it looks like, and check what it looks like. Actually, just change the endpoints instead of the z-axis. So we're going to increase the weight by using the slider, so the optimization prefers z-axis change. We're going to press optimize again, and looks like it's better than before because it prefers the z-axis change instead of the endpoint change. So then I'm going to continue modeling while I elaborate on what I've just said on the parameter thing. So basically, you draw 3 strokes on the canvas, and you hope that you could define a local axis precisely, but that's not always the case. So sometimes you hope that the optimization tool could help you correct your mistakes or correct the inaccuracy, but sometimes the inaccuracy is not caused by your drawing, but actually the ambiguity in image-based modeling. You just want to modify the z-axis, the screen-based z-axis actually. So this is actually a balance between the endpoint change and z-axis change. When you just want the algorithm to correct your inaccuracy of drawing, you need to select a value that prefers endpoint change. But if you just want the model to move along the z-axis, you should choose a value that prefers z-axis change. The parameter selection is just a balance between the user input and the geometric feasibility. So you actually should consider well before you decide what the optimization parameter is. Okay, so look as if we have added 5 constraints to make the model feasible. And please notice that we have chosen a parameter that prefers z-axis change. This has the assumption that our user stroke is precise enough, and we only want the model to move along the z-axis, the screen-based z-axis. So then we could do some manipulation after we have used patch match algorithm to remove the foreground and added texture to the model. We could select the model we want to rotate and alt-click on the main axis. copy and paste the candle lifter and rotate it in all. So in this example, we are going to model this beautiful ornament. It actually looks like a candlestick. So right in the middle of the picture, there is a straight pole, and on each side of the pole there are 3 bending cylinder meshes that, you know, they are connected to the main pole. And at the end of each connector there is a tiny small cylinder which we are now modeling. So actually, when you draw the first cylinder, you could always press Ctrl C and Ctrl V and use the middle mouse button to pan this model, actually to translate this model to the position you desired. And then you could always hit the shortcut R so that the model could then be snapped to the boundary of the image, just like this. When I press R, and then it's going to be snapped to the image. After modeling these tiny cylinders, we're going to model the main pole, and then we're going to model the 3 bending cylinders on each side of this main pole. So after we have finished, we could change to the shaded mode to check whether there are any problems in this model. So actually in this case we found that the generalized cylinder part are not attached to the main part correctly. So we are going to use geometric constraint to optimize this model. So first of all, we are going to attach each small cylinder to its generalized part by adding 2 constraints to each pair. In this case, we are adding 2 constraints like the parallelism and overlapping axis endpoints, so that we could make sure that these 2 parts are attached together correctly. Please note that we are using the optimization parameter which prefer the z-axis changes, which is very suitable for this optimization. And if you actually want to change the endpoints, you could always use a slider to change it. After we have added all the constraints to this generalized part and to make them coplanar, we could find that the optimization result is quite good and the model is finished. Next, we are going to select all of our models and use patch match algorithm to give it texture and remove all of the foreground. Then we could actually manipulate this model a little bit, like what has been done in the original 3sweep paper video. We're going to actually rotate all of these components about the main axis. We could rotate anything about one specific axis by using the Alt modifier. Basically, in manipulation mode, you select the meshes you want to rotate and Alt click on the main axis, and then you rotate. The rotation will be bound to be, you know, the rotation axis will be the meshes that you select. Also, we could rotate a mesh around itself by selecting model and then alt click on the model again. So the last example would be a tap. This example is very tricky. Maybe it is the trickiest model in all our demonstrations. You could switch to border edit mode if you have the software to check out what do we need.